Now we want to talk about how to look at the correlation or relationship between two variables, how they linearly move to each other. So there's a two measure we call the covariance and correlation coefficient. So are they one of the measure commonly used is they move above the mean together or below the mean together, right? So if they all move together in the same direction, right, then we want to a positive measure. If they move in the opposite direction, we want a negative measure. So if you're given an n observations and each observation x1, y1, and x and y, and so n pairs, and what we do is look at how they above mean and below mean together. So we just each time we subtract its own mean for x, subtract own mean from y. If x above is mean and y above is mean, right? X above is mean, y above is mean, multiply together will be positive, right? If they both are below the mean and both number with negative, so they end up with positive, right? So if one above mean, one below the mean is negative, right? So that's why if this term at the end become more positive, they move together above the mean same direction or below the mean in the same direction. Okay, if they're more negative, this measure negative is more time they are one is above the mean, one is below the mean. Okay, it's negative, it's fitting our idea of negative, right? Suppose mean is here, x is here, y is here, x is here, right? Above the mean, below the mean, then positive, right? If one is below the mean, one is above the mean, then it's negative. So that's exactly fit our idea. So here we also have the same idea. We have a sample adjustment term, which replace n by n minus 1. Okay. And as we have seen, same as coefficient correlation, coefficient variation, we normalize by mean, right? So here we normalize by variance. Okay. So this is the population one, right? So we divide by this sum over n, but the n cancel out, so that's why we have this. So basically just sum of the product deviation for mean and squared deviation for mean for x and y. Okay, and this we can solve must be between -1 and 1. If 1, they fall into a line. If -1, they fall in a negative line. If 0, then it's not really you cannot see a relationship. So remember, this is linear. Okay, it doesn't. If it's non-linear, then this measure is not good. So it's only good for linear relationship. So look at the graph, right? So this is a positive relationship, right? You can draw. You can easily see a line with fit here, right? Positive, right? Because the mean is above here, right? Then when it's above mean, it's tend to above mean. When below mean, tend to below mean. Okay, this negative. Okay, you can easily think this line fitting here. Then the mean is around 40 for x and around 50 something for y. And then you can see if one is above the mean, y is below the mean. If x below mean, y is above mean. So it's negatively related. The sample counterpart is the same because this divide n minus 1 and the standard deviation also divided by n minus 1. So they are exactly the same. So there's no sample correlation coefficient because they're exactly the same. So we also mentioned there's a line to be drawn. That one will be covered in a regression class. They will talk about how to actually draw a line there. But for the moment, this correlation coefficient or covariance is a good measure of how they're related. Okay, in linear term. Okay, it's non-linear, then it's not a good measure, but that's linear. The basic one, okay, is how to measure the relationship between two variables.